Hello, in this video we'll be talking about rational equations and how to solve them. Now, what is a rational equation? It's an equation where we've got a variable in the denominator, like right there. Now, how do you solve this sort of equation? Well, first of all, it's easiest if we can write both sides as a fraction. So if I look at that right-hand side there, maybe it'd be best to write as 3 over 5x plus 1 is equal to 2 over 1. And now what I'm going to do is I'd like to get that 5x plus 1 up on the main line. It's down in a denominator right now. So I'm going to multiply both sides by 5x plus 1. And what we're going to get is 3 times 5x plus 1 over 5x plus 1 is equal to 2 times 5x plus 1 over 1. Now you'll notice, of course, that we get a 5x plus 1 that cancels out on the left-hand side, and we're left with 3 is equal to, well, something over 1. I can just write it as 2 times 5x plus 1. Now another way of looking at this is that we just brought up the 5x plus 1 and multiplied it by that 2 there to get my right-hand side. And we can think of the 1 down here being brought up and multiplied by the 3 to get that left-hand side. But now what we have is a simple linear equation. So I can just go ahead and solve it. I'll expand the right-hand side. Need lots of room for this question. We get 1 is equal to 10x, and so we've got that x is a tenth. So this method here we call cross multiplication, and you can use it whenever both sides are just a fraction and there are no other terms. Now, of course, if one side is not a fraction, we can always turn it into 1 by putting itself over 1. All right, let's try another example here. If we look at this example, we can do our cross multiplication. Now, this negative sign right here, I can think of it being either attached to the numerator or the denominator. It's my choice. So let's attach it to the numerator there. So for my left-hand side, I'll get 6 times y plus 5. And on the right-hand side, I'll have negative 1 times 3y minus 2. We'll expand out both sides. Collect our like terms. And there we have it. Now, let's move on to another example. We've seen that we've got linear equations. Let's take a look at question number 4 here. Again, we have this little trick that since the right-hand side is not a fraction, let's make it 1 by putting it over 1. And when we do the cross multiplication, we get 6 is equal to z minus 3 times z plus 2. So we're going to end up with a quadratic equation this time. I'll distribute everything out. And let's bring everything over to that right-hand side there. Okay. And again, we can think maybe of a factorization. Two numbers that multiply to give negative 12 and add up to give negative 1. Well, negative 4 and plus 3 fit the bill. So that tells me I've got two solutions here. Z equals 4 and Z equals negative 3. Now, all along, we should very carefully check our solutions. If we plug z equals 4 into the original equation, we'd have 6 over 6 on the left, which is 1. And on the right, we'd have 4 minus 3, which is 1. Left-hand side is equal to right-hand side. Z equals 4 is a solution. If I try z equals negative 3 in the original equation, I get 6 over negative 1 is negative 6. And I get negative 3 minus 3, which is also negative 6. So that also checks. Now, let's take a look at this number 6 here on the bottom of page 3 there. Again, I can do my cross multiplication, and I get 2 times y squared minus 3y plus 2 is equal to 5 times y minus 1. Expand out both sides. Okay, we can bring everything to the left-hand side there. Now you may know how to factor this, in which case just go ahead and do that. But if I try the quadratic formula, I'll get 11 plus or minus the square root, negative 11 squared minus 4 times 2 times 9, all over 2 times 2. We'll continue along. Now, 121 minus 72, we're going to end up with 49 under that square root. Square root of 49 is 7. So if we take 11 plus 7, we get 18 over 4. 18 over 4 in lowest terms would be 9 over 2. And if we take 11 minus 7, we get 4 over 4 is 1. So we get those two different solutions. But we should be careful here again to check it out. Now you'll notice if we try to take the y equals 1 and plug it back into this equation, we're going to end up with a denominator of 0 there. And we can never have that. So our y equals 1 does not pass the check. Even though it's a correct answer that came out of our work, it is not allowed to go back into the original equation. So it's not a solution to the original equation. It was a candidate, but it turns out it's not valid. So it's not a solution. Okay. The 9/2, well, it's a little bit trickier. I'll let you take a few minutes to plug it in for yourself and verify that it is a solution. Also, please take this time to finish off the other few questions that we didn't look at. If you have any questions, come and see me, please.